Hello, I'm MJ Shaney, Cloud Solution Architect at Microsoft on the Emerging Opportunities team. This video is a project overview of FastPass, a quick start project we made demonstrating the use of text analytics for health to accelerate patient intake. We made both a low-code and a pro-dev version of the project, featuring the use of Power Platform and a static web app with Azure Function API, respectively. This video will be split into two parts. The first will be an overview of the low-code version from my colleague, Francisco Ruiz. The second will be a recording of a demonstration I gave on the pro-dev version.
Hello, I'm Francisco Ruiz, a Cloud Solution Architect at Microsoft. My goal today is to demonstrate the low-code version of FastPass, which is meant to help digitize paper forms and help extract key patient information. Before we get into the technical overview of the project, let's dive into the potential use cases for a tool like FastPass. Patient intake information is often manually transferred from written forms to local storage, and from there structured to be HL7 compliant in FHIR storage. Any later medical observations must also follow a similar journey, which is greatly inefficient, but also opens the doors to potential inaccuracies. FastPass aims to ease the conversion process of written documents into FHIR data by merging the capabilities of text analytics and human oversight. Here is the solution architecture diagram. We are using a Power App which submits input to a Power Automate flow. Our flow is responsible for taking a scanned document and running optical character recognition to generate raw text. This text is then fed to Microsoft's Text Analytics for Health Azure service, which is able to create a FHIR object from text using AI to pull out various entity types. The corresponding JSON is parsed, and the desired components are returned to the Power App as flow output properties. This output is passed to a FHIR-powered data connection within FastPass. This custom connector was built by the Health and Life Sciences Emerging Opportunities team to make interacting with an Azure API for FHIR service simpler. This connector supports FHIR API calls within the Power App environment, allowing for direct creation of new patients on a FHIR server. Now let's see our solution in action. We'll begin by uploading an image file of our scanned text, which any document scanner could generate. The Process Scan button will trigger Power Automate flow, and very quickly we are able to see a form preview of the patient information contained in our scan. We have the opportunity to oversee the data that was automatically collected before we can choose to submit it to our FHIR server. Everything here looks accurate, so we'll go ahead and click Submit. Now, if we take a look at our FHIR server, we should see a new patient entry.
Okay, so this is a demo of a technical demonstration of the pro-dev version of FastPass. For anyone who doesn't recall, FastPass was created as a demonstration of the power of Azure Text Analytics for Health. And we had in mind with it patient intake as our use case, where FastPass would accelerate patient intake by extracting medical information from paperwork and then preparing it in a digital form for review by a front desk worker who could then approve it before submitting it to any FHIR API. In our low-code version, built in Power Platform, we had used an optical character recognition service as well to extract the text from scanned images to kind of mock that use case out. And then the text would then be sent to Text Analytics for Health. Whereas in this pro-dev version, we chose not to spend time working on that OCR element in favor of exploring in more depth the non-FHIR formatted information from Text Analytics, as well as the observation FHIR resource type. As far as the technical background for the pro-dev version, we went with a static web app that runs a Blazor WASM frontend and a linked Azure Function API. The API serves as a proxy to both Text Analytics service as well as the Azure API for FHIR that we save our data to. And when we work with the application locally, we're going to use the static web app CLI, which is going to act as a proxy and replicate the way identity would work when deployed. So let me go ahead and kind of show this off. So when we're working with it locally, we set both the API and the Blazor UI to debug. And then with the static web app CLI, we're going to just run this command, and it's going to start the proxy, and we're telling it where we're running both the front end and the back end, and that's what that -I is. And it does not handle HTTPS well at this point, so we just give it the HTTP location for these. So once it's finished running, it's going to give us the port that we can go to for the proxy variant. It's going to decide not to work this time. See if, oh, classic mistake. I'm in the wrong directory. So you do need to be in the directory of your project.
We can submit an issue for that later.
Yeah. Why can't it just intuit
right
where I want my project to be? So anyway, once you get that going, you got your URL, and where it's locking in here, which is just the debug from Visual Studio. This is going to say there's nothing there, but then when we log in with the proxy, it'll give us this great page where we can add some user roles, username, we'll get user ID, we could add some claims if we wanted to mock those out, and then we can log in. Once we're there, we provided 2 pages. One, this one's going to be for showing the FHIR bundle output from the text analytics for health service. And then this one's going to show more of the kind of generic text analytics output. So not necessarily specifically medical, because you can do linked entities as well with text analytics. But the text analytics for health does have specific health information as well, but the sort of POGO format is the same as in non health related instances. So we'll start with this since it's a little bit easier to digest. So we'll grab our example text, which has some information about a patient, and it will also, when we later look at FHIR information, show some observation data. So when we submit this, it's going to send this text to the Azure API, or Azure Function as our API. That sends it to Text Analytics for Health, which comes back with all these entities. These entities right now are sorted by category, and it'll show you where in the text it found that information. So, you know, the offset, and then it'll tell you how confident it is in that. So for some of these, it's pretty confident, and then for others, not so much. So that's kind of the very basic use case. We did find for both FHIR and the text analytics for health that there is some issues with serialization if you're using the SDK. Now with FHIR, they provide you with a serializer and parser that you can use for their objects. So there are workarounds there. But for the text analytics for health, the SDK doesn't really expect you to be moving its objects between like spaces, I guess you could say. So if you tried to serialize them, they will throw errors because they don't have public constructors. So we had to make some objects to serialize those for us. And we've reached out to the team to with some feedback with that in mind. But going to the FHIR data, when we submit here, we will get patient information, just like in the low-code version, but we've also worked on showing observation data. So we have coding displaying. The text analytics for health will provide lots of variants of the coding, so different systems to which the coding can belong to. We have hard-coded our form here to display with priority the UMLS. And then if that's not present, it'll display the SNOMED. And if that's not present, it'll just display the first coding that it finds. Because otherwise you would see lots of different codes, but they all mean the same thing. And that's just how the FHIR format is for those. So for both of these, we can submit the patient, and then that will get created, and you can see the ID down here as a notification.
Question for you as you're going through that. It looked as you were going through that like there were several observations that were part of it. Is that just like each of them banned as you went through it, and that's just repeated for each one? Okay.
Yes, there are multiple observations. I had not determined a way to represent the observations nicely with like a name to indicate. I originally went with like the number, so how like observation 1, 2, 3, 4, and then I removed that and did not put it back in place. But a lot of them have kind of overlapping information to display since they all relate to the same subject. And a lot of them relate to the same encounter. But some of them have different things that they're talking about in general, though. So, for instance, this one's talking about the fact that the patient was observed to be thin, whereas this one's talking about I'm not going to pronounce this right, but thoracoscopy. I'll just
sounds good to me.
It wall in my head, yeah. But we also made it so that you can submit these as well. And then those observations will get created. We originally tried with making the observations a proper form where you could change it. But the complexity of the observations made it so that we just didn't complete that in time for this demo. But that is on our list of things that would be ways to just generally improve this ProDev version. One would be displaying some of the more complex FHIR objects or elements of FHIR objects nicely. So for instance, value didn't quite get as far as displaying that in a neat way. And then the effective, there are a variety of different ways that effective can be displayed. So there is an instant that it's an effective. There can be a time period. There could be a specific date time. And then there's one more, which I don't recall off the top of my head, but these different formats are ways that you have to check for in the FHIR SDK. And then you'd have to figure out how to display that accordingly. And just going through each of the different variants, ran out of time for that. But being able to display those neatly would be a good way to improve this. Another consideration that we found was that when you are submitting information to the Text Analytics for Health service, you are submitting an array of strings, and then each string correlates to a page result, and then that page result gets its own corresponding FHIR bundle. So, Matt, I believe you had brought this up with the low-code version where you had you were aware of clients out there who were interested in trying to stitch together multiple paged documents, either in the OCR piece or maybe in the text analytics piece. But we haven't really figured out what are the implications or ramifications of putting together multiple FHIR bundles, because each page that you would get would have its own FHIR bundle, and then how would you combine those so as not to lose information or overwrite information that existed in one or in both. So that was a piece that we encountered but had not resolved. And then sort of in addition to that was that we noted that whenever you get a FHIR bundle back, no matter what's in that bundle, so let's say we just submit Advil, there's always a patient object that's returned from that. So it didn't find any observations, but no matter what, it's always going to generate a patient, an encounter, and a practitioner, even if there's no information about those. So that was an interesting consideration that we discovered when using text analytics for health.
And that's just based on a feature of the service, I assume then?
Yes, that's our understanding.
Okay.
But the fact that we were able to use the SDK at all was awesome. The beta just came out where you can use the SDK to request for the FHIR bundle to come back with your results. So that was new for us versus the in the Power Platform version. The connector that the reason why we pivoted to Power Platform in the first place was because the SDK wasn't out, and there was a connector for the text analytics for health, even if we didn't ultimately use that connector because it also didn't support the FHIR bundle. It just made our development faster for our first cut.
One other question, in the considerations that you had, it looks like this is assuming like each thing is like each of those text blobs that you were putting in there, it's assuming a new patient. Did you explore anything around being able to look for like matching against an existing patient in a FHIR repository, or was that just not scope for the exercise here?
We started that and then have moved it out of scope. But the idea that we had started to look at was for, at least for patients, was that you could take you could offer the user the ability to say, I want to search off of these two pieces of personally identifiable information and use those to filter for existing patients and say, okay, I have reasonable cause to think that these two patients are the same. We didn't feel that there was a programmatic way where you could say definitively, yes, this patient that we've just pulled from text analytics is this patient in your FHIR system, because any element of those piece of information could have changed in between when you first uploaded them and not. Even things that are typically static, like social security number, can ultimately change. So that was the where we were going to go with that, but building that out, we felt took a backseat to building out the observation.
Yeah, I think that makes sense too. I mean, it's a real problem and I would love to tackle it, but I think there's already a bunch of third parties out there spending lots of money to try and do patient merges. It's not good, right? Like,
yeah, well, and I was thinking, Jeff, in the context of the scenario that had been laid out before was,
Yeah.
you know, you have a staff person at the front desk who's doing this to help speed up some of the intake process.
yes.
I mean, it could very well be, you know, an existing patient, but it's more of a human process to kind of initiate this from a known patient, or, you know, start like they're completely new. But that was why I was curious if it was in scope for the exercise here, or just
Yeah, I always go back to the whole decentralized ID thing when I hear about these, because to me that's the only answer here. We're just not ready for it as a society. But yeah, I'm following you. I think this is good. Did you guys look at the data yet to really, like, I see that you're breaking it all down. That totally makes sense. But I don't know, maybe running it by somebody in Kathy's team even and saying, hey, here's what text analytics took in. Here's the observations that came out. How good are we? I mean, is it good stuff?
Yeah, we haven't run it by an expert per se, but we started looking at it just from a spec standpoint, just making sure that it's
Okay.
actually returning something that's in spec. And so far, everything it seems
Oh,
to be
good.
within the
Okay.
spec. I haven't seen anything yet that sort of jumps out as just wrong.
Okay.
But it would be nice to also have, from a clinical standpoint, does this data actually make sense?
Yeah,
so
because I think at
that
some level, and this is probably more in your camp, Joe, but at some level, now we've got data sort of, we'll call it parsed out for now. What do we do with it? What action do we take? What can we learn? Like, that's the next piece of this, I think. I mean,
exactly, yeah. And we talked about that potential downstream application, like to your point, now we have the data. Now we know the data is good. What sort of business problems can we solve? Whether it's the workflow thing that Ola had mentioned last time we met, or just other use cases around that. Now that we know the data is actionable or data is of good quality, what things can we do? So at one of the next iterations that we do will definitely be a downstream use case.
Cool.
To summarize this video, FastPass is a demo application on how you might leverage text analytics for health to accelerate patient intake. When working on this project, we found that optional parameters to receive a FHIR bundle was very powerful. There's both an excellent SDK and Power Platform connector to simplify the use of the API, and both are still receiving great updates, such as being able to use that optional FHIR parameter. Some sticking points that we found was that the FHIR bundle was at first not supported by the SDK or the connector, as well as the serializing to JSON was not supported by the SDK. Both of these hurdles, however, are quite surmountable. During the making of the project, the SDK received a preview update enabling the use of the optional FHIR bundle. Regarding the serialization, however, simply creating your own POCOs to provide that serialization was sufficient. Overall, Text Analytics for Health is an incredibly powerful tool to help you get the most out of your medical documents quickly. Thank you for listening. If you like this video, or just generally want to be more connected to the health and life science developer community, please join us on our Discord server at aka.ms/hls-discord. We're looking to build a technology-agnostic community for anyone technical in the health and life science space to share ideas, network, and seek help with anything they're working on. Hope to see you there. Thank you.